Hi guys, so today we're going to go over X and Y intercepts. So X-intercepts are just points on the X-axis graphically. So if I were to plot any point on an X-axis, let's say -1, that point is -1, 0. So notice that the Y value is 0. So anytime you have an X-intercept or any point on the X-axis, algebraically, you would solve for the X-intercept by making Y 0. The Y-intercept kind of has the same relationship, but it's the point on the Y-axis. So if I were to put a point on the Y-axis, this point would be 0, 2. So notice how the x is 0. So any point on the y-axis, x would be 0. So algebraically, we would make x equal to 0. So I'm going to give you two examples. The first one is going to be a quadratic equation. And from here, we're going to find the x and y intercepts. So to find the x-intercept, you're just going to make y equal to 0. So if I were to make f of x, which is just y equal to 0, 0 equals x squared plus x minus 2. So you're solving for x, meaning this is a quadratic equation. You're going to be factoring, so multiply first times last. I need two numbers that multiply to be -2, which is a times c, and add up to be the middle number, b, which is in front of that x, and that's a +1. So the two numbers that multiply to be -2 and add up to be 1 are going to be 2 and -1. Over each number, we place a and x, which is just 1x, but we'll just write x instead. And then we have, bring down the 0, equals, the first fraction is the first parentheses, x plus 2, and the second fraction or parentheses will represent the second set of parentheses, which is x minus 1. So it's factored. The other side is 0. You can use 0 product property, meaning set each parentheses equal to 0. And I'll get x equals -2 and x equals to 1. That means if I were to start graphing this quadratic function, the 2 points on the x-axis would be at -2 and at 1. So it just helps you find distinct points within your graph. So the x-intercepts are the points on the x-axis. Now for the y-intercept, you're just going to make x 0 this time, and it will represent the point on the y-axis. So given this function, I'm going to just change the f of x to y, and instead of x squared, I'm going to write 0 squared. Instead of plus x, I'm going to write plus 0, and then bring down the constant, which is the -2. So PEMDAS tells me exponents first, 0 squared is just 0, 0 plus 0 is 0, and 0 minus 2 gives me -2. So the y-intercept, or the point on the y-axis, is at -2. And kind of from there, you can already see what your quadratic function, which is always going to be a parabola, looks like. Okay, moving on to a rational function. So from here, I'm going to separate first. We're going to find the x-intercept, again, by making y equal to 0. So instead of g of x, I'm going to write that as y and then set it equal to 0. This rational function is 2x minus 3 over x minus 1. I have to solve for x, so the first thing I'm going to do is multiply both sides by this denominator of x minus 1. It's being divided by x minus 1. I'm going to multiply both sides by x minus 1. So on the left side, anything times 0 is just 0, which is nice. The x minus 1 divides out, leaving you with 2x minus 3. Again, the goal here is to solve for x. So I'm going to add 3 to both sides. And I will get 3 equals 2x. And then from there, divide both sides by 2. So x will equal 3 over 2, which is 1.5. So on the x-axis, you'll just make a point at 1.5, the point between 1 and 2. To find the y-intercept, I'm going to just make x equal to 0. So g of x, I'm going to change it to y, equals 2 times 0 minus 3. I know you know what 2 times 0 is, but I'm going to write everything out. And then 0 minus 1. So I'm going to solve the numerator and then the denominator. So 2 times 0, PEMDAS, multiply first. 2 times 0 is 0. 0 minus 3 is negative 3. Over 0 minus 1 is the negative 1. And then we have negative 3 over negative 1, which is just 3. So on the y-axis, I will have a point at 3. And that'll help you just start getting key points for your graph. All right, guys, hope this helps.